Welcome everyone. This is on.NET show where we talk about .NET, and today I have with me Immo.
Yep.
Hi Immo.
Hey Burden, how's it going?
Good. So today we're going to talk about NetStandard. What is NetStandard?
Yeah, so in one sentence, NetStandard is essentially a way for you to write libraries that will be consumable on a variety of .NET platforms, not just one of them. So we've done this before. We had similar artifacts like portable class libraries that did this before. But the really cool thing about NetStandard is that it's just one. There's no profiles. There's a simple versioning story, and it's the set of APIs that we promise we will have on all the platforms today as well as in the future. So it's a really strong commitment from our side.
Okay, so we could stop here, and that sounds pretty simple.
That sounds awesome, right?
Well,
right.
Yeah, but the devil is in the details, of course. So when you said we've done this before and there are various forms, is it a case of that XKCD cartoon that actually popped up in the comments of your post? The cartoon is about so there are 14 standards, so that needs to be cleaned up, and what happens is that you end up with 15 standards.
Right.
So are we doing that?
We are and we aren't. .NET has always been about giving you a very productive way to write your applications for a particular platform, right? And when we shipped in 2002, I think was the first public release, we had two application models, really. We had like the desktop application model and we had the web application model. And it essentially had the exact same framework underneath it, right? It was one giant framework, but it would basically allow you to do whatever you want to do. And then later on, we decided that we want to support more different app models. We had the phone, we had Silverlight, and all the other ones. And it would have been nice if they all would have had the same APIs. But the problem is once you step back and look at the larger picture, .NET Framework was really for PCs or servers. Phone was really for smaller devices. And when we launched the first version of Compact Framework, the devices were really constrained. And so in a sense, if you want to really exploit the underlying device, the underlying environment you're in, you kind of have to cater to that environment. So you can't really have just one flavor of everything, right? You really need to have, for example, P invokes. You need to have specific technologies that are specific to the device and the scenario you're going after. But at the very bottom, if you really look at the primitive types in strings, collections, even networking and XML, there's really not a reason why these pieces have to be different for every single .NET platform. And .NET Standard is really about giving you this foundational piece that you can rely on to be exactly the same everywhere. And if you build other libraries that sit on top of .NET Standard that just basically are expressed in terms of the standard, they can also run everywhere. So you can essentially build a complete library ecosystem on top of .NET Standard, and those things can go everywhere. So JSON.NET would be a good example for that.
Okay, so from what I understood from what you said, the base of this is a common API,
right?
Which I've read and heard a few people describe as being to .NET what POSIX is to the Unix world.
Right.
So a common API, great. Is there also a common implementation of some of this or all of it? Is it a standard class library or just a standard API?
Yeah, you can think of .NET Standard essentially as an actual specification. So meaning there is a set of APIs that we say, here's the shape of the APIs that we expect platforms to implement. So .NET Standard today is actually implementation free. It's literally a specification that is satisfied by multiple .NET implementations. So .NET Framework is one, .NET Core is another one, Xamarin is another one, Mono is another one, Unity is another one. They're all they all some of them share code and they're forks of each other. So for example, Mono, Xamarin, and Unity, they're all kind of the same base implementation, customized and tweaked. But it's similar to Linux when you think about the different distros, right? They all share some sort of common code base, but yet they're still distinct entities by themselves.
Okay. So this is the blog post that you published and that we are linked to in the description is about NetStandard 2.0. But we already have occurrences of that standard. We have how many do we have right now? How many versions? And how does the versioning work with all this?
Yeah, so the idea of the versioning is, I mean, that's contrasted with portable class libraries because that's the thing I hinted at in the introduction. So what portable class libraries did for you, and we shipped this, I think, 5 years ago probably. The idea of portable class libraries was, okay, there are multiple .NET platforms, but there's no toolable way for you to write a class library that runs on multiple of them. Right? You have to basically create one class library for each of those, and then you can do some code sharing, which is actually a pain in the ass in Visual Studio. At least back in the day it was. Now we have actually shared projects where you can do this easier, but the point is that you really want one library or one binary. So what Portable did is it basically presented you with a dialog that says, here's all the platforms and their versions. Which one do you want to run on? Then you do your selection, and then we go in some dark corner and say, whatever this is, let's give you this surface area, right? And this is where the profile numbers came in, and that's where you have like so many different versions of Portable essentially. And it makes it very hard for you to reason about how much API service do I get when I bump my version number or I drop my version number or I select or add platforms.
It was even worse when you were using external packages because you had to find packages that had the same intersection of platforms that you were interested in. And
right.
Very quickly your intersection was becoming null.
Yeah, if you visualize it, right, you can picture a Venn diagram of 3 circles, right? Once you have 6 or 7 or 8 or 9, your head starts to melt. And you can think of these profiles as all these different overlaps between these circles. With .NET Standard, it's simpler because .NET Standard is basically just one thing that versions over time, meaning the higher the version number of the standard, the more APIs it has. But also the lower the version number, the more platforms have it already implemented, right? So the idea is every .NET platform implements .NET Standard, but by the time they do it, they may only support version X of the standard. And so when you choose the version number, you should choose the lowest one you get away with because you have the broadest reach in terms of platforms.
Is that still true with 2.0?
Sorry?
Because 2.0 seems to be supported by more platforms, not less. So is that an exception to the rule, or what's happening here?
Yeah, it is one of those things that I think I did not do an amazing job on the blog post to try to explain this. So basically the problem that we face is when we shipped .NET Standard originally, we shipped it as part of .NET Core, right? .NET Core 1.0 shipped 3 months ago. And that one essentially had already support for .NET Standard. But at the time, .NET Core was basically the outlier when you look at all the .NET platforms that are out there, meaning it has the fewest APIs, it had the most drastic differences in some of the API areas, right? Reflection comes to mind here. And we basically said, this makes it super hard to target .NET Core, so we should fix this regardless. But then we also said, how do we make sure we don't do this mistake again? How do we actually get to a point where we can say, this is a foundational piece, we no longer mess with that? And so .NET Standard is essentially that thing. But at the time we did it, we kind of had to make it work for what the platforms that we had at the time, which was .NET Core. And so .NET Core 1X actually is, in terms of API service, you can think of it as a subset of .NET Core. That's really what it is, which is not as big of an API set as you would like it to have. With .NET Standard 2.0, we're basically taking a step back and say, okay, let's revisit the core pieces and make sure that when you ignore .NET Core, you just look at, let's say, Xamarin and .NET Framework. What does the intersection look like? Because that's probably a good proxy for things that should really be everywhere. Because Xamarin already supports multiple platforms, Mono supports multiple platforms, so there are probably APIs that are meaningful in the cross-play case.
Would it be fair to say that NetStandard 1.x were what we were able to provide at the time, and 2.0 would be what we were after all along, but that takes time.
Exactly. So if you look at 1x to 2.0, yes, 2.0 has more APIs. But by the way we did 2.0, we also said, okay, we really want to make sure when we ship 2.0, we have a decent platform coverage, right? If we say 2.0 supports only the latest version of the framework, then that's great on paper, but in practice, many people cannot target the latest version of the framework because, for example, they have to deploy to Azure, or they have a large in-house IT that just painfully rolled out 4.6, and that may not, it takes another year or so until they actually get the latest version. And so you may not be able to choose the latest version, which makes .NET Standard not that attractive. So we said, okay, how can we make sure that .NET Standard 2.0 runs on 4.6.1? And as it turns out, .NET Standard 1.5 and 1.6 have about 30 APIs that are, so the standard difference between 1.4 to 1.6 is very small. It's like literally just 30 APIs. And so we said it's probably better to basically say 1.5 and 1.6. Let's declare them mistakes. Let's call them dead essentially, and say, let's pretend .NET Standard has 1.0 to 1.4. And then when you look at .NET Standard 2.0, it's an actual strict superset in terms of platform support and in terms of API support.
Okay, so that's probably something that we should repeat.
Yes.
So nobody should use 1.5 and 1.6? Is that what you're saying?
I would basically, if you would start a new project, I would really avoid taking dependency on 1.5 and 1.6.
Okay.
Because
so either use 1.4 or lower, or wait for 2.0.
Or wait for 2.0, right.
Okay.
Because then you don't have any problems, right? Like I mean, technically what we will do in tooling is we will let packages install that have a dependency on 1.5 and 1.6. Because in most cases, it will probably just work out anyway at runtime. But like strictly speaking, there will be APIs in .NET Standard 1.5 and 1.6, which 2.0 doesn't have. And we just made that so we can say, yep, .NET Framework 4.6.1 can actually support .NET Standard 2.0. So generally speaking, the idea of the standard is, that's why I said that this 1.5, 1.6 is a one-off. We don't intend to make breaking changes. Our intention is the standard versions linearly, and it will always have more APIs than the previous version.
Okay, so breaking changes is actually something that I wanted to talk about as well, because it's pretty unusual for Microsoft to make breaking changes. So between what versions is the breaking changes? Is it only between 2.0 and 1.6?
Yeah, as I said, like think of .NET Standard as concentric circles.
Yes.
And as you're going out, the version number goes up, and you have more API surface, right? When you look at the picture, what happens is that 2.0 is essentially a strict superset of 1.4.
Okay, so there are no breaking changes between 1.4 and 2.0. So if we do what you said earlier to forget about 1.5 and 1.6, then there are no breaking changes.
That's correct.
Okay, well, that makes it simpler, I think.
Yeah, that should make it simpler, yep.
Okay. So exactly what platforms are supported with 2.0?
Yeah, so we have this giant table. Like it's one of those things where it took us like
but exactly. I don't want to talk about the matrix.
So like I think the easiest way to visualize it is essentially to say, assume all .NET platforms that are out there today support .NET Standard. So that's a given. So the only thing that
they have to. Yeah. That's the law.
Well, yeah, we also designed the standard in such a way that actually holds true. So we're working with Xaml, we're working with Unity to make sure that there's not any APIs in 2.0 that they don't have, right? So, so they're all supporting a version of the standard. The question is, which version do they support? And you know, if you look at .NET, it's similar to Linux, I guess. When you look at you have multiple distros in the same way we have multiple different, you know, I call them flavors of .NET, right? There's .NET Framework, .NET Core, Xaml, and Unity. And they all have independent versioning, right? I mean, .NET Framework is in version 4.6.2. .NET Core, we just shipped 1.0. Xamarin, I don't even know their version numbers. So they all version independently. So each version of those platforms will snap to some of the versions of the standard. And so like the matrix gets only complicated because you want to know which version of the standard is implemented by which version of which platform. And it's very hard to get this into one single table.
Yeah, but let's focus on 2.0.
Okay, 2.0 is easy. 4.6.1 will support it. .NET Core, I think we call it probably 1.3 will support .NET Standard. Maybe 1.2, like the version numbers are, you know, they're all in the future.
That's the future.
So it's the next version of
.NET Core of the time will support it.
Xamarin will support it. I said I don't know their version numbers. We are working with Unity to make sure they support it as well. Unity just moved to the latest version of Mono, which should basically give them .NET Standard for free. Forget anybody in that picture? No, I think that sounds about right.
Okay. Okay. So how do you deal with platform-specific stuff? There is a lot in .NET Framework that is platform-specific, such as the registry, ACLs, stuff like that.
So generally speaking, the idea is, so first of all, one of the other reasons we have the standard is because we want to give you what we call a toolable artifact, right? Like as I said, Portable was a tooling story for building libraries that work on multiple platforms. And the same we do it for .NET Standard. So you will be able to say, file new class library .NET Standard. And then you, instead of giving you the PCL dialog, you basically just have to select the version number of .NET Standard. And so when you start writing code, after you did file new project, the idea is the only APIs you will see are APIs that we know will work everywhere, right? So for example, the registry is not an API that will work everywhere because it's inherently a Windows-specific component. I mean, Mono has done some work to emulate it over INI files, but depending on how you use the registry, you may fall off very quickly. So it's probably easier to assume registry is Windows-specific and leave it at that. Eccles, the Windows permission model, it's the same thing, right? It's very tied to Windows. There's other things that are very specific to the .NET runtime you're using, right? We have a JIT-based runtime, which basically compiles code on the fly. We have a runtime that compiles code up front, which we call AOT. It's ahead of time. So there's certain technologies in the framework that do runtime code generation. And again, they may not be available because, for example, if you target iOS or UWP, the store doesn't allow you to submit code that basically emits code on the fly. So you cannot use ref-emit in that context. So there will be some of APIs that are not available everywhere. And so the idea was, we say the foundation of .NET Standard itself will only have APIs which will work everywhere. So when you do file a new project, that's the only APIs you see. Now, what happens if you want to target .NET flavors that only run on Windows? Let's say you only care about let's say .NET Framework and then maybe .NET Core, and you always run on Windows. In that case, there's nothing wrong with using the registry. So you will be able to use the registry from a .NET Standard-based library. The only difference is that now you actually have to add the reference. You have to say right-click, you browse, and then the package tells you, well, I only run on Windows. And then you explicitly take the dependency on that. And then our idea is, we probably don't have that in the very first release of .NET Standard 2.0, but the idea is that long-term we also give you tooling for that. So when you actually now start consuming these bits on other platforms, we actually give you build time warnings or errors that tell you you're using technologies that are not supported on your platform. So you don't actually have to F5 the app and wait for platform not supported exception. But the idea is, yes, you will be able to take dependencies on those things, but you have to opt in. We don't want to have this lowest common denominator tooling because it doesn't work.
Okay, so when you take one of those platform-specific libraries, you're still able to consume NetStandard libraries, of course, but you yourself are stepping out of NetStandard.
Right.
Let's say your library, your target is still NetStandard. It just happens that you have a reference to a library that is not. But
well, you can think of it as think of NetStandard, as I said. If you think of it as in terms of API surface, it's basically giving you a vocabulary that you can use to exchange types, right, or APIs in general.
But so I was going to ask, how do your consumers down the stream know what to expect from your library in terms of portability?
Yeah. So think about how we would implement the registry, right? So we would implement the registry in such a way that the registry itself is a class library that targets .NET Standard. Mm-hmm. So it can use all the APIs that .NET Standard has to express itself, like it can take strings and all the other things, right? And then it will have p invokes to Win32 in the implementation. .NET Standard itself has, the APIs you need to use for p invoke. It has, the Marshall types, it has the attributes, so you can literally compile this thing against .NET Standard. But at runtime, because you rely on p invokes, your problem essentially is that you will not run on Linux, right? If you try to run this library on Linux, the p invoke will not be satisfied. So in a sense, you can think of those libraries essentially as .NET Standard-based libraries, but they just have a runtime dependency on Windows. But they are not themselves specific to some version of .NET.
Right.
They're just specific in the implementation to some operating system. And there may be other cases. As I said, Reflection Emit is a great example of a library that is specific to the .NET flavor because, if you do runtime code generation, that's not a p invoke. That's actually the runtime has to know about you, and there's an intimate coupling between this library and the runtime. So this is the kind of libraries that only we can provide you with. But from the outside, they will just look as libraries that support .NET Standard, and they just have deployment restrictions on the operating systems or target frameworks.
Okay. So who defines the NetStandard, and what level of community involvement do you have in that decision process?
Yeah, so .NET Standard right now is open source. It's in the GitHub Foundation, in the GitHub organization for the .NET Foundation. So it's .NET/standard on GitHub. The way we define it right now is, as I said, it's somewhat mechanical because we basically just say, okay, what do we have in the intersection between .NET Framework and Xamarin? Because it's a good starting point. And then we are working on implementing, the Delta in .NET Core because it's the only one that doesn't have the APIs. All the other platform owners, whether it's Xamarin, Mono, or Unity, for very few exceptions, they already have all these APIs, so there's no buy-in necessary from them. But we are talking with them about what do you think about these APIs being part of the standard, and the idea is that we will have a review board that is essentially all the vendors of .NET, which is basically my team. It's the Xamarin team. It's the Unity team, and we are basically reviewing those API additions that we do to the standard, and we make sure that we can implement them everywhere. And so the idea is that every platform vendor can innovate and can create their own new APIs that their flavor of .NET has. And then they can say, we think this is a really good API. Everybody should have that API. And then they bring it back and say, what do you guys think? And then we basically start implementing it everywhere and then we adding it to the standard. This is not something where the community can do, I think, a lot because it's really a standardization process more than anything. You have to agree on what the API shape is. And then every single vendor has to implement them. Now we do have right now conversations around APIs we should add to the standard, which everybody already has. A good example here is system.data. We got a lot of feedback around that we should just have some part of ADO.NET in the net standard. And so that's something that we are talking right now, and it looks like we will probably add the core part of ADO.NET, which is the provider agnostic pieces, the database agnostic pieces, data table, data set, the abstraction. We will add them to the standard.
Yeah.
So that's the kind of feedback we're getting right now.
Okay. So it's my understanding that there is something quite specific about the way it works on 4.6 because 4.6 is already out. It doesn't know anything about NetStandard. So how do you actually make it work?
Yeah, that's one of those things that is, black magic. So ideally, what you would think would happen is when the platform supports NetStandard, they basically have to have something in their platform that basically maps the NetStandard to their implementation. And you can think of it as a very simple artifact, which is .NET Standard is basically one assembly. It's called netstandard.dll, which is one giant assembly that has the entire specification in it. And then the idea is each platform can decide how they want to realize that. They can have it in one giant assembly if they want to, but probably nobody does that. Like a good example is .NET Framework, right? A good chunk of NetStandard lives in MS-Collib. Other pieces live in System. Other pieces live in System XML. Some things will live in System.data. And then basically what the platform does is just takes this DLL and maps the types from the DLL to their implementation. And that's the kind of thing that we expect platform owners to ship as part of their platform. As you pointed out, the outlier is 4.6.1 because 4.6.1 has already shipped. So there's nothing in that thing that knows about NetStandard today. But the idea is that when you reference the NuGet package for NetStandard, we just make sure that when your app deploys, part of your application deployment will have that artifact that maps it to the rest of the .NET framework. And that's what you will have to deploy. But it's just one DLL you have to deploy, essentially.
Okay, so for library developers out there, what tools exist to determine what they can target and when and
right. So we have this thing
use.
called API port, which is available as a Visual Studio extension. There's also a command line tool available. Basically what it does is you can say, here's my application or here's my my folder with all my libraries. And then you can basically run a tool that will tell you on which .NET platforms your binary can run on based on the API usages that it has for the framework. And that tool basically treats .NET Standard as it treats any other .NET flavor. You can say, tell me whether I'm compatible with .NET Standard 2.0. And .NET Standard 2.0 right now is being actively defined, so we update this thing pretty much on a daily basis. So right now it's possible that when you run the tool on Monday, you get different results by Thursday because we still, mess with the definition.
Get better results.
Hopefully better. Sometimes you will probably change that.
And it can actually tell you about several platforms at the same time. You can run it against several things.
Yeah, basically
it gives you an Excel spreadsheet, basically.
Right.
Where
basically, think of the spreadsheet as you have your modules on the one hand side, or like from this side, and you have the platforms to the right, and it will basically just give you like a thumbs up or thumbs down. And like for your modules, it's basically just a percentage, how many of your API usages are compatible with that platform. But there's a secondary sheet where you basically see every single API you have been using from the .NET framework or from the .NET flavors, essentially. And then it tells you for each platform, yep, that one is in or that one is out. So you can refactor your application appropriately.
Yeah, so we'll provide the links to the tool in the description. My personal preference is to use the command line because
it's faster.
Not just that, it actually gives you better results. I think you have more flexibility in what you do.
Interesting. I thought it's the same tool, but I haven't used the VSX integration either.
I think the VS extension pretty much gives you the option of generating one thing, but you don't really have a lot of flexibility on how you parameter. That's maybe I'm missing something. I don't know.
No, I think the part is when you right click, there's no dialog that asks you which platforms. But there's like under tools options you can configure which one you want.
Oh, I don't know.
But you have to set that up front.
Okay. Another thing about the command line is that you can actually integrate it into your CI.
Correct.
And you can actually monitor the progress of your compatibility as you go, and that is very nice.
That is very nice. Yes. The other thing we're doing right now is we are talking to people on like the very highly used libraries like JSON, and we talk to them and make sure that, can you target .NET Standard and like what does it mean? So we really want to make sure that you have all the APIs that you need to be successful. And for the most part, as I said, that's a given because the way we construct this thing is basically very conservative. Most of the existing APIs will be there. And the outlier really was .NET Core. So we basically think of .NET Core just growing as a result of us doing .NET Standard 2.0, which for the most part should just mean you can take existing .NET framework-based assets, and so long as they don't do anything crazy like popping UI using WinForms, you should be able to recompile them against NetStandard 2.0, and it should just work. In fact, we even go a step further and say, well, if you have all the APIs, why can't we make the existing binaries just work? And in fact, we have a compatium that will allow you to consume a binary that is compiled against .NET Framework in the context of .NET Standard. Of course, we cannot cheat physics. They will only work when the APIs are there. Yeah. But for the most part, we think, especially for .NET Framework, most of the APIs, when you have application workload independent artifacts, you are very likely to have the right level.
Okay, so there is a good chance that you might actually be able to use many of the libraries that exist today without the author of the library having to come up with a new version. That's nice.
No, that's not our preferred model, obviously, because you're basically throwing a dice. But we think it's very. I mean, one thing we learned.
It sounds a little like what we have to do today with import in Project JSON.
Right. Yeah. You basically you force it, right?
It might work, but
it may not.
Yeah.
But I mean, we think it's a very important transitional step, right? If you want to convert your library to .NET Standard, if we would only allow you to use libraries that are compiled against .NET Standard, then we have this, problem where you basically people at the bottom have to start first, and then the rest can actually take advantage. If we say anybody can start at any given point in time, you get to critical mass much faster, right? Because there's no coordination that needs to happen, and especially it's also important for libraries that you have in-house where. Half the libraries, the owner may have left 6 years ago, right? So you may have to, it takes a while for you to convert that.
Yeah, I think that's an interesting thing about the evolution of .NET that's going on right now, which is that there is a smooth transition, hopefully. At least we're trying to make that transition as smooth as possible. And there are existing .NET implementations that you can still use today. I mean, not everybody has to go to .NET Core or NetStandard right away, right?
I wish
we have this advantage in comparison with starting really from scratch.
Right.
So, but the flip side of it seems to be like there is a fair amount of fragmentation that's going on with all of our runtimes. So is .NET Standard a way to avoid that fragmentation?
Yeah, I mean, if you look at today's picture, I mean, I've drawn this picture many times. It's like, think of like a bunch of verticals, like rectangles that are all independent of each other, right? .NET Framework, .NET Core, they don't share any binaries, right? They're like, yes, we share some code, obviously, in the implementation, but they're literally all independent, and same is true for Xaml, and same is true for Unity. And with .NET Standard, we basically introduced this box at the bottom where we can say, no, this is the same box everywhere, and you can rely on that. And that is super critical for library authors, but it's also super nice for application authors, because if you switch between, let's say you are building multiple applications and you don't actually build binaries for NuGet, right? Just say you have an in-house, WinForms app for the administrative backend, you have a mobile client using Xamarin, and then you have maybe a website for other clients. Well, it's really nice if they all have the same APIs, because then you can just copy and paste code between different projects, and if you switch between projects, you don't have to relearn how string looks like on this .NET platform, right? It's really nice to have that consistency as well. And for the most part, we have this by convention, so it works relatively well even today. But with .NET Standard, we really say, nope, there's actually a much stronger commitment on, no, they should be the same shape. There's no reason why string needs to look different between different .NET flavors.
I've seen some comments on the blog post about languages. Is there anything that needs to be explained about how NetStandard works with the various languages that exist on .NET? Is VB completely supported, F#?
Yeah, like the thing with .NET Standard is essentially, I haven't talked about languages at all in the blog post, because none of this has realistically any bearings on languages per se. I mean, .NET Standard is really just talking about API availability and capabilities of the .NET runtimes and OS support, which is all language independent. I mean, there's a reason we call us the common language runtime, right? Like we have IL that is all language independent. Now, of course, there is some tie to the languages themselves. You can think of the runtime library support that each language has. I mean, Microsoft C# has Microsoft.C#.dll, VB has Microsoft VB.dll, F# has F# Core, and so the question is, are those libraries supported on .NET Standard? And the answer is yes. We will have support for Microsoft C#, we will have support for VB, we will have support for F#. The only difference is those runtime assets are not part of .NET Standard, because why should they? I mean, they're usually MSIL only anyway, so they can be just regular, libraries targeting .NET Standard, which means they can go anywhere the standard is supported, which is everywhere. But we don't want to put like language-specific parts into the .NET Standard because it's nonsensical.
But is there going to be a delay for those language-specific features to be?
No, that's exactly the point why we don't want to put them in the standard, right? So if imagine some language wants to innovate,
is there anything in those libraries that wouldn't work with NetStandard?
Oh, you say like with the no? I think we looked at this. I'm pretty sure we have the report already. I think F# Core today already is a portable class library, so that will just work. VB is basically MSIL only. C# is pretty much MSIL only. So we already have portable artifacts for them as part of .NET Core for the most part. And that's the thing that would just bind against .NET Standard as it is. So no, there should be no difference. The only tricky piece, that is a bit more on the tooling side is, of course, you will have to do some work in the templates, right? When you do file a new project, you expect to find a template for C# to do a standard library. And the same way would you expect something for VB and something for F#. But it's just templates, but that has nothing to do with the standard itself.
Okay. I also want to talk about some specific APIs and how we are going to handle that. And I want to start with one that is probably a little tricky, which is UI. Because cross-platform UI is definitely not easy, and there are many ways to skin that cat.
Yep.
So what's going on there? Is there anything currently in NetStandard about UI?
No, like today, .NET Standard is, as I said, it's really like the foundational piece that is app model independent, right? It has no bias to whether it's a UI that is on the server with HTML or a client-side UI. It's just all UI independent. Now, when you look at cross-platform UI, the one thing is there's like three different things I've seen that are happening. There is either there is a specific component that is specific to a given platform, like WinForms comes to mind here. So it looks really good on their platform, it doesn't work anywhere else. Then there is the Java Swing approach, where you basically have the UI layer itself written in such a way that it's portable, which means you have the same UI everywhere. It looks equally shitty everywhere, but at least it works everywhere. And then you have something like Xaml Forms, which is basically an abstraction over the individual UI stacks. and then you can have something that you can express yourself as being portable, but you can basically still on each platform tweak it a bit to actually accommodate the actual platform. Today, none of these things exist on top of .NET Standard. I would expect once we introduce the standard and once we get more libraries on the standard, we will see things like Xaml forms, for example, be expressible themselves as a .NET Standard-based library, and then they basically have different implementations for different platforms. So they will not work everywhere, but they will be very, very portable, and you can write your own code that is basically just targeting Xaml forms, writing a data grid or whatever, and you don't have to necessarily go to every single platform. But today, there's a clear separation. .NET Standard is the thing that goes everywhere, and UI is not part of that because UI differs very, very starkly.
From what you've been saying, I've been hearing mostly about controls and displaying rich information. What about interaction? What about gestures and maybe even speech or the inputs? The input side of the user interaction.
Yeah, so one thing that we have as part of .NET Standard is general purpose infrastructure you would use for data binding, right? Like things like iCommand, things like iProperty notified, iNotify property changed, or iNotify collection changed. So you can express the code that you would data bind to from the UI in terms of .NET Standard. And to a certain extent, if you say gestures, you would think that, for example, speech recognition we don't have today, but it would be relatively easy to imagine that you have components that target the standard that allow you to express that, and that they have OS-specific implementations behind them, similar to the registry. But we don't have that today, but I would expect that to happen over time too.
Okay. There are a few commenters who are very vocal about XAML.
Yes.
So XAML is, in itself, if you just look at XAML and not the actual technologies that use XAML, is system.xaml something that could make it into the standard without breaking that platform-specific boundary?
If you think of XAML, it's essentially an XML-based serialization format for object graphs, right? Really, that's what it is. The tricky thing with XAML is it basically started as the language for WPF or WPF-related technologies. So there are some things in the XAML parser that were very specific to the way WPF works, like think of styles and static access and how you can inject instances and all of that. As far as I can tell, system.xaml has abstracted a good chunk of that. So I think you can probably just take system.xaml and have that be workable UI independent. It's just work. As far as I can tell, there's nothing fundamentally wrong with that. It would just take somebody to actually do it. And right now, as I said, what we are focusing on is things that already are everywhere and have a very high demand. And system.xaml, yes, there are very many people that really would like to see that. But if you put this in perspective to the other questions and other demands that we have, like for example, XML transforms or XML schema or JSON.NET and all the other things, they're very vocal, but they're also in terms of customer size, they're just dwarfed by all the other things we have to do. And we only have so many resources right now, so we want to focus them on, put them on things that immediately everybody benefits if we do that. But I have no problem with imagining at some point we will have system.xaml as a fully portable component sitting on top of the standard, and then maybe we even put it in the standard if it takes off. There's nothing wrong with it.
So I get the thing about order of execution and how you prioritize things. What about contributions?
So the tricky thing is, the standard, as I said, is basically a specification. So contributing to the specification is not helpful by itself, right? Somebody actually has to implement it in the platforms. And the thing with .NET Standard is it's by definition a codified API set that each platform has to implement. So it doesn't have an implementation by itself. Now, what we can take contributions for is basically, think of the .NET Core project on GitHub right now, like the CoreFX repository, which has a bunch of libraries that are general purpose. A good example here is immutable collections. Immutable collections today is not part of .NET Standard either, because it has never shipped in any platform. It was always what we call an out-of-band thing that sits on top of the platform. That is probably a library that we will basically just change the implementation to, instead of targeting .NET Core, it will target .NET Standard, which now means immutable collection can go anywhere the standard is. And so if you want to, for example, provide us with a new library that doesn't exist yet, and you want to make sure it runs everywhere, yep, you would contribute that library to CoreFX, and you would basically say, I was target the .NET Standard, and then that means that the library can go everywhere. Now, it's not in-box everywhere, but honestly, you may not even want it to be in-box everywhere. I mean, we had this discussion with JSON.NET where somebody said, why didn't you add JSON.NET to the standard? And the answer there will be, if we would have done it, we would have done the community a disservice. Because first of all, James Newton King does a really amazing job today to make sure JSON.NET runs everywhere. And that is totally a function of him being able to make changes on his own. If he has to suddenly coordinate his API set with 6 different implementers of .NET and the standards committee, he can version the API set, but boy, it will take a long time, right? And so is that really worth it? Because really from a customer standpoint, the only difference from being in the standard is that it's basically available when you do file a new project. So JSON.NET is available to you, just right-click and add a reference to JSON.NET. And if that thing targets the standard, it can go anywhere you can go. But it also means if James Newton King wants to make an update on Tuesday, you can consume it by Wednesday because you just right-click the package and say update. If it's part of the standard, it can only ref at the same cadence as the standard refs, which by definition also is slower because we have to move every single .NET platform forward. And that's why we don't want to boil the ocean here by saying everything goes into the standard. But we really want to make sure that we have a foundational piece that already is stable, that already is in all the .NET platforms. It is already a set of APIs everybody loves and everybody depends on. That should be just in the standard because it makes everybody's life much easier.
Okay. So you've talked about data already.
Yep.
So apparently it's very likely that the base stuff is going to make it. I understand that there is something specific about regular expressions as well, compiled regular expressions in particular. So what about that? What's going on with this?
So when I said in the blog post, I said when you look at platform-specific APIs or runtime-specific APIs, how do we model this, right? And so for things that are basically forming their own component, like reflection, emit, or registry, we just extract them from the standard and make them libraries that sit on top of the standard. But what happens for technologies like Regex, where Regex is basically just normal API, you would expect it to be in the standard. But there's this one part on Regex where you can say, do not just create me this NFA or DFA, actually compile IL and run that Regex as a compiled program, essentially. And that thing can only work when you are on a runtime that actually has reflection emit. So the question is, how do we deal with that? One option is we can remove those APIs, which means there's no way for you to add it back. It's just gone when you target the standard. Another way would be to say we leave the APIs there, but the APIs may either throw when you're on a platform that don't have them, or we emulate them. And so my example was expression trees are emulated because you can compile an expression tree, you get back a lambda. And that lambda on a platform that supports IL generation would just compile it down to IL, and you get basically a pointer to a function that literally just executes. On platforms that don't have reflection emit, you just get an interpreter that just walks the trees and does whatever
So you use the APIs, but they might not perform.
They may not. They have very different performance characteristics, but they will work. So there's API removal, API extraction, emulation, and there's throwing. For Regex, I said, well, we throw when you actually specify in the enum that you want to compile Regex. Many people say, why would you do that? Why wouldn't you just emulate that? And I talked to my dev team, and it turns out that originally we threw at some point. There was some reason why we did it, and nobody could remember why it was. Now we basically say, no, if you pass in, I want to have a compiled Regex on a platform that doesn't support compilation, just nothing happens. You would just have the normal NFA and just interpret that and say, yep, you don't get to get it to compile. So it would just work as you would expect it to.
Okay. Let's finish with app domains.
The reason for the end, right? So app domains. App domains is an interesting part because app domain there's the type app domain that has a bunch of APIs on it and facilities that have nothing to do with app domains. They have to do with the current app domain, but they're really just queries for the current state of the world, right? You can basically register an unhandled exception handler. You can ask for the loaded assemblies. You can ask for the base directory of the application. None of them have to do with app domain creation, right? They're just for your current app domain. They could have lived anywhere else, but for better or worse in V1, we put them on app domain. So in .NET Core, we really tried to say, let's not have app domains. So we introduced a new type, assembly load context that does something similar to isolation. We have app context that give you things like base directory. But the problem is, like, if you have a large chunks of existing code, it's just this like very slow, death by a thousand paper cuts problem where you have to move every single usage of app domain dot unhandled exception handler or base directory to this other type over there. That we said it's just not worth it. It's so much easier to just say we have the app domain type in the .NET Standard, so you can do, the unhandled exception thing, the base directory thing, the loaded assembly thing on all the platforms, and they will always be supported. There's one API on app domain that actually has to do with app domain creation, and that is create domain. And we said, yep, this method will work on platforms that support app domains, and on platforms that don't support app domains, the method will throw. So right now we have no plans to add app domains to .NET Core. So when you actually compile against the standard and you call, app domain or create domain, it will throw on .NET Core. It will work fine on .NET Framework, and I think it will also work fine on Mono and Xamarin. So there's some discussion going on whether we should have app domains, but right now we said for .NET Core we don't want to have it. But the type is in the standard, and it's mostly there because there's so much existing usage against non-app domain related functionality that we felt it's easier to just put it in.
Okay, cool. Thanks, Immo.
Sure thing.
Is there anything you want to add that we forgot to talk about?
I would like to get more feedback. There's a decent amount of comments that we got on the blog. The GitHub repository right now is a bit lonely, so if you have questions or I try my best to answer them. There's actually an issue filed in the core repo, which I called RFC, ask all your questions here, because I want to create an FAQ where I basically do the same thing you just did with me. I just want to have a bunch of questions and have answers for them. I can just point people to that. And I want to grow that to have a more compelling list of answers. And then the other thing I would tell people is, if you're a library author today and you're creating NuGet packages, take a look at NetStandard, use API port, give it a run on your libraries and see whether it works for you. If it doesn't, I would like to hear about it. And that's pretty much it.
Excellent. All right. And Kendra, do you have... we haven't heard you at all today.
Hi, everyone. Yeah, got here a little bit late. Sorry.
No.
So bad at clocks.
But you do have some news. You do have a new video.
Oh, yeah. I posted a video for installing VS Code on a Mac and running C# with .NET.
Yeah, so
Channel 9.
We'll put the link in the description as well. And people should check it out. It's fun as usual. So thanks again, Immo. Thanks, Kendra, for being here at all.
Thanks for having me.
Sorry.
No, seriously, it's no big deal. And we'll see all you guys again next week. Bye.
Bye-bye.
Bye.